Welcome back to Go Figure. Today we're on lesson 56 of Saxon Algebra Half, equations with mixed numbers. Please like the video and subscribe to the channel if you haven't already. Thanks. Here are a couple warm-up problems. Please pause the video and work them out and then press play when you're ready to check your answers. Okay, 3/17 times x equals 12. Now to solve this, we need to multiply by the reciprocal of this coefficient. So we want to multiply by 17 over 3. I'm going to rewrite the rest of this problem. Equals 12. And then what we do to one side of our equation, we need to do to the other to keep it balanced. So we're going to multiply that by 17 over 3. These will cancel out. We're going to be left with x. And we can do some cancellation here. Factor out a 3, factor out a 3 there. And then we have 4 times 17, which is 68. So x equals 68. Okay, 2/5 of y equals 11. So again, we need to multiply by the reciprocal. So we're going to multiply by 5 halves, so that y is isolated. And then what we do to one side, we need to do to the other side of the equation. So multiply by 5 halves. These cancel out, leaving y by itself. And then we have 11 times 5 is 55 over 2. So y equals 55 over 2. Our learning objectives today are to solve equations with mixed numbers. So for equations with mixed numbers, we need to convert those mixed numbers to improper fractions. And then we can solve by isolating the variable, which usually means multiplying by the reciprocal of its coefficient, like we just kind of went through in the warm-up there. So here's an example, 4.5 times x equals 7. So the first step we need to do is just change this mixed number to an improper fraction. So that would make that 9 halves. 4.5 is 9 halves. X equals 7. And then to isolate the x, to solve for x, we need to multiply by the reciprocal here. So multiply that by 2/9. And to keep our equation balanced, we need to multiply by 2/9 on the right side. And then these two fractions will cancel out, and we'll have x equals 7 times 2 is 14, and then that would be over 9. So x equals 14/9. Our next example, we have mixed numbers on both sides of our equation, so we'll have to change both of them to improper fractions. So here 5 and 2 halves would be 27/5 times y equals 3 and 3/8 is 24, 27, 27/8. And then to isolate y, we're going to multiply by the reciprocal, 5 over 27. Multiply our other side by 5 over 27. These fractions cancel out, and we have y equals, and we can cancel out these 27s, and then we're left with 5 over 8. So y equals 5/8. Let me go back. Okay, so here's 2 practice problems for you to try on your own. Pause the video and then press start when you're ready to check your answers. Okay, our first problem, let's convert these mixed fractions into improper fractions. 2 1/4 is 9/4 times p equals 8.5 is going to be 17 halves. And then we want p by itself, so we need to multiply by the reciprocal, multiply by 4 over 9. Do the same thing to the other side of our equation. These cancel out. We're left with our variable. And we can cancel out, factor out a 2 here. So this would be 1, and the 4 would turn into a 2. So then we have 17 times 2, which is 34, over 9. P equals 34 over 9. Our next one, let's change these mixed numbers to improper fractions. We'll get 21 over 5 times x equals 7 halves. 7 halves. And then we're going to multiply by 5 over 21 on both sides of our equation. Fractions cancel here. We have x equals, and then we can factor out a 7 right there and here. So now we have 1 times 5 over 2 times 3. So x equals 5/6. In conclusion, we want to always convert our mixed numbers to improper fractions, and then we would solve by using the methods that we've learned before. Here's your problem set for lesson 56, and any questions you have, you can post in the comments. And don't forget to like and subscribe. Thanks, and we'll see you next time. Have a good day.